Hello and welcome. The subject of the following movie is general intelligence. So what is the difference between artificial and general intelligence? Well, the term artificial intelligence in our days has a kind of bad reputation because companies, programmers and researchers, all too reckless, give the predicate intelligence or artificial intelligence to their products. But until today, all these artificial intelligence products are island solutions, specialized solutions, isolated solutions like pattern recognition, speech recognition, handwriting recognition, or data mining. So I started research in this area more than 20 years ago, and the results of my research and my algorithms now reach a stage where I can go for partners and cooperatives to turn all these algorithms, all my knowledge into products and therefore for money. So if you are in the business of artificial intelligence, if you are looking for new technology, for new algorithms, for a breakthrough in general intelligence, then you shouldn't hesitate to contact me. In the first part of the following movie, I give an overview about the status of today's artificial intelligence research along the paradigms of information technology. Then I talk a little bit about the aspects of artificial intelligence regarding religion and philosophy, and then you see two demonstrations of basic principles of information processing, where the second demonstration is the most important because I demonstrate induction and deduction. Induction is the ability to conclude from common knowledge to some special, and deduction is the ability to following the logic of the induction. And so I show it on a dialogue, but what I want to show or demonstrate with this dialogue is that behind this induction and deduction there are basic principles. That's not specially programmed, that's not an island solution. So this is the demonstration that the algorithms or the basic principles of induction and deduction in a neural net are discovered. So now please enjoy the movie. Hello and welcome. In this little movie I will demonstrate you a breakthrough in artificial or general intelligence research. Why do I talk of a breakthrough? Well, decades of research in the area of artificial intelligence along the paradigms of information technology just spawned some fairly usable systems in the area of pattern recognition, especially speak and image recognition and handwriting recognition. Then we have systems in the area of data mining, which are mostly based on statistics, and we have so-called assistant systems like chatbots, which are able to execute the commands of a user or are able to adapt themselves to the wishes or attitudes of a user. So that's all what traditional research in the area of artificial intelligence achieved the last decades. And I said fairly usable because most of these systems need, strictly controlled environments. And if this is not given, then they fail. And nevertheless, these systems, especially pattern recognition, is far, far, far away from the capabilities of a biological brain. Even a mouse has a better pattern recognition than the best artificial system on the market. And finally, these systems in the area of pattern recognition, data mining and assistant systems, chatbots, are far, far, far away from the actual claim, namely to create a thinking or a general intelligent machine. Of course, there are countless products out there on the IT market which have the predicate intelligence or able to learn. But a closer look shows that these systems, they aren't intelligent and they are not able to learn. Because just changing some thresholds or weights in this so-called artificial neural nets, that's not learning and that's not intelligence. These artificial neural nets are just conditioned like Pavlov dogs. Stimulation in, reflex out. Nevertheless, again, countless companies, product managers, researchers, programmers, all too reckless, give the predicate intelligence and learnability to their products. And it is really pretentious if researchers call the rules along the artificial neurons are processing numbers, if they call these rules learning rules. But what is so attractive on the issue general intelligence that every year around the globe billions and billions are spent to achieve this goal? Well, it feels like as the computer had conquered our complete daily life. But closer look shows again that the biggest part of our daily life is free of computer. For instance, there is no system on the market which is able to fix a breakfast, drive a car and then fly an aeroplane. To do so, that really requires a flexible general intelligence. And so a tremendous burgeoning market is waiting for him or those who come up first with a general intelligent system. The question is why decades of research in the area of artificial intelligence didn't lead to a general intelligent system. Why this research still stuck on pattern recognition, data mining and some dumb chatbots. It looks like as there would be a barrier, a wall between, on the one side, this research along the paradigms of information technology and on the other side, this general intelligence. And for 80-90 years now, researchers and scientists bouncing against this wall, but weren't able to get rid of this imaginary obstacle. So the question is again, is there a door somewhere in this wall? Is it possible to find this door and open it to prosper this huge, virtually emerging market which is waiting on the other side? Well, some scientists and especially philosophers and religious scholars say no, that's not possible. One of them is John Searle, a philosopher and professor on the University of California, Berkeley. He claims that intelligence is caused by a spooky, immaterial, invisible thing called spirit. And as machines can't have spirit, the question is why? Machines never can become real intelligence. They are only able to imitate intelligence. But on the other side, until today, the adherents of this assertion that the answer to some fundamental questions. How do this immaterial, invisible spirit interact with the matter of our brain? And where is it located in the brain? Although the question is unanswered, where does this spirit come from? Do it emerge with the brain, or do spirit linger around in the universe? And if a brain is growing in a uterus, then they say, oh, there is a brain for me. I go down, that's mine. You see the problem? And also the question is, what happens to this spirit if the brain dies? I know that sounds very similar to the concept of a soul, but the concept of a soul had nothing to do with the spirit that John Searle claims. But the most important question is, why for all in the world should this spirit, or a spirit which causes intelligence, and I must say, if it is true that intelligence is caused by a spirit, why for all in the world should this spirit only be dedicated to a biological organ? Because our brain is just an organ like all the other organs in our body. And there is no spirit in a kidney, in the stomach, or in the bladder, or in the heart. So again, why should this cosmological spirit only be dedicated to a brain on this little planet somewhere in the nowhere of the universe? If we demystify this spooky thing called spirit, and if we accept that intelligence is the sum of some cognitive and logic abilities, of fantasy, creativity, and the ability of anticipation, and if we assume that these abilities are based on some fundamental principles of information processing, then we are back in reality. Our brain is the best proof that billion years of evolution have led to these basic principles. But evolution is not a conscious process. Evolution is a dumb process of try and error. So evolution is not able to create something. Evolution is only able to lead to something what is already there, what is immanent in nature. I started researching in the area of artificial intelligence about 30 years ago, and in the very first beginning I realized that the paradigms of information technology will not lead to a thinking machine. So I decided not to become a member of the artificial intelligence research community, because I didn't want to get influenced by foreign ideas or concepts. So I decided to follow my own path. And it took me a few years to perceive this imaginary obstacle which separates the paradigms of information technology from a thinking machine. And it took me a few more years to do some fundamental considerations. And then I had a eureka moment. Then I realized, first, this general or basic principles of information processing are accessible, because a dumb process of evolution was able to find them. So I should be also able to find them. And then I saw the door in this wall. The conclusion was that it is not possible for a thinking machine to create another thinking machine. It's not possible to make a drawing or a schematic of a thinking machine. It is the goal, the aim must be to find these basic principles of information processing and use them. Then you can draw, if you have these basic principles, then you can draw or make a schematic of an intelligent machine, including these basic functions, because then you know what to do. After a few years of intensive research, I discovered a remarkable new type of neural net. This neural net has nothing in common with standard neural nets or a neural net you maybe know. The first major difference is that in this new type of neural net there is no presetting. So there are no preset layers or clusters, there are no preset input or output neurons. This neural net starts with one single neuron and is growing by the incoming data. So new neurons are built and interconnected. That means further that the intrinsic semantic of the incoming data is not represented as weights or thresholds on the synapses, but by the structure of the neural net. The second major difference is that this net is a kind of omnipotent. That means the neural net do not have one single functionality. So it is possible, just by connecting the neurons in a different way, the same type of neurons with the same algorithm in the neurons, it is possible to build one part of the neural net as, for instance, associative memory, and the other part for pattern recognition. And this leads to the third major difference. It is possible, by connecting the neurons in an appropriate way, to build some iterative processes. So it is possible to do some algorithms, some little programs with the neurons. And this is really a big new difference to standard neural nets. So this is perfect PIM, process in memory, because it is possible to build as many algorithms you need in the neural net, and you can locate them direct there where they are needed. So there are no bottlenecks, because the interconnection is very close. There are no buses anyway. So you can build the process, for instance, which is handling the associative memory data. You can put this process directly beneath the associative memory neurons, and so on. And so let's talk a little bit about information processing. So far we knew three types of information processing. One is how a computer is processing data. A computer is still a computer and is only able to compute numbers. But it is possible to build a numeric model of the world. So the computer is able to compute the world, or the model of the world. And this is how computers are usable, or why they are usable. The second type of information processing takes place in our brain. It's totally different. The world, the model of the world, is not represented by numbers like in a computer, but in the structure of the neural net. Similar to my neural net. So I claim that I discovered how to represent or how to build a model of the world in a neural net, and how to process this, or how to deal with this model of the environment. And the third type of data processing takes place in a biological cell, where the DNA is the software, the code, and the cell organelles are the hardware. So now this new type of neural net fills the gap, or makes it possible now to do data processing just like the human, the biological brain is doing. And so I was very, pleased that this discovery of this new type of neural net, and after a few years, as I was able to use this tool to study intelligence or general intelligence, my assumption, as I started researching in the AI, that intelligence or general intelligence is based on some basic principles of nature. So this was confirmed. And I was also, very amazed that basic principles of nature are not only, or you cannot only find in physics or chemistry or mathematics. No, also in information processing there are some basic principles of nature. So on the left here you see a schematic of my neuron. You see that the neuron consists of a cell core, a dendrite, and an axon. So it's very, very close to the biological idle, and the incoming stimuli on the dendrite are processed in the cell core, and then the neuron fires or fires not. And on the right side here you see an example of a PIM process in memory. Again, it's just the question or the way how you connect the neurons, the same type of neurons. They act as an associative memory, or they act as an algorithm, or for pattern recognition, a special neural net for pattern recognition, whatever you need it. It's possible to just interconnect the neurons to get new functionality. And what I want to demonstrate today are the practical realization of six of these basic principles of nature, which are vital, for my opinion, for general intelligence. So these are conditioning, rule detection, situation classification, associative memory, induction, and deduction. These are the six most important basic principles of information processing that you need for general intelligence. And this is what I want to demonstrate now.
May I introduce Robina? Robina looks like a chatbot, but she isn't a finished one. But it would be very, very easy to turn her into a high sophisticated chatbot. But the aim of this program is to demonstrate 4 of these basic principles of information processing I mentioned before: conditioning, association, rule detection, and situation classification. Here, situation classification only takes place in a dialogue, but if you are familiar with chatbots or programming chatbots, then you know that a dialogue rapidly can turn into a very, very high complexity. For a better understanding, I put a schematic of Robina here, and here you see the center part, neural net. And this neural net at the moment consists of one single neuron. I can show you. Here you see there is one single neuron. And here we have in this function blocks in combination these basic principles of information processing. And even if Robina is dumb because her brain is empty, she's talking, but this is because here these functions are active and producing response, and this response is translated by a text generator into speech. Of course, as Robina lives in a standard IT environment, she needs some interface. You can see this interface as drivers if you want, and they are operating system depending. And here we have the interface for the keyboard. Then here we have interface for any input I will demonstrate later. And of course we have an interface for action because Robina is able to trigger some actions. And finally, you see here in the dialogue some misspelled words, but this is because of the limitation of the speech generator. Sometimes I have to misspell the words to get the correct pronunciation. So now I will demonstrate this functionality in a shape of a dialogue, and I can step through the dialogue here, and I did this because I want to save time and not to waste time by typing in the complete dialogue.
Hello.
My name is Robina. To whom do I have the honor to talk to?
Manfred.
Hello, Manfred. I appreciate chatting with you.
Who is taller, Tom or Mike?
Sorry. Can't answer that question correctly.
What is the color of the sun?
Sorry. I don't really know.
It's yellow.
I will remember that.
How much is 5 plus 7?
Yellow.
I put these questions here on the beginning of the dialogue just to prove that there is no chat log behind Robina, and there are also no keywords.
How is iron?
Yellow.
Hard.
That's very interesting.
And here you can see that Robina gives the wrong answer, or or maybe not the expected answer, but this is correct because a learning system can't give the correct answer from the beginning. Otherwise, if the learning system would know every answer, then there is nothing to learn. So it's important what answers Robina gives after the correction. So in the following you see now first conditioning, then association, which are very similar, and then step by step you will see rule detection and situation classification.
How is the sun?
Yellow.
Hot.
Okidoki.
How sun?
Hot.
Color sun is?
Yellow.
Iron how?
Hard.
What is yellow?
The color of the sun.
How is?
Hard. And hot.
What color has iron?
Is yellow.
Light gray.
Understood.
What color do you know?
Is yellow. And light gray.
What is a city in Germany?
Yellow.
Munich.
That's very interesting.
Color iron has.
Light gray.
Who is the Chancellor of Germany?
Yellow.
Angela Merkel.
I will remember that.
Who is the President of the USA?
Angela Merkel.
Barack Obama.
Okidoki.
Who is Chancellor?
Angela Merkel.
President is.
Barack Obama.
Who is who?
Angela Merkel. And Barack Obama.
Who is the President of France?
Barack Obama.
Francois Hollande.
That's very interesting.
President.
Barack Obama. And Francois Hollande.
What is the square root out of 144?
Is yellow.
12. Chancellor.
Angela Merkel.
France.
Francois Hollande.
What is Munich?
A city in Germany.
Paris is in France. Square root of 625.
25.
Merkel Angela is who?
The Chancellor of Germany.
In France is.
Paris.
Tom weighs 65 kilograms. Where is Paris?
In France.
Tom is 6 feet tall. Who Barack Obama is?
The President of the USA.
Paris.
Is in France.
Who is taller than Mike or Tom?
6 feet tall. And Angela Merkel. And Barack Obama.
How much is 7 plus 8?
Hard. And hot.
15. Mike is 5.5 feet. How much is 121 plus 3,254?
3,375.
Red is a color. Who is taller than Mike or Tom?
6 feet tall. And Mike is 5.5 feet. And Angela Merkel.
Tom is taller than Mike.
Thanks.
Yellow is a color. Is Tom taller than Mike?
Yes.
What is a city in Germany?
Munich.
Hamburg.
Hello, Manfred. I have detected a contradiction. To the question, what is a city in Germany? You answered, Munich. And now you said, Hamburg. Is Hamburg a correction? Or is Hamburg an information?
Info.
Additional property realized.
A car weighs 1,100 kilograms. Who is taller than Mike or Tom?
Tom is taller than Mike.
Mike weighs 70 kilograms. How many colors do you know?
Hard. And hot.
I have told you 2 colors.
Nothing found to count. Could there be a problem with plural?
The plural for color is colors. John is 5.7 feet. A ship is 30,000 kilograms. How many colors you know?
I know 2. red, and yellow.
Who is taller, Tom or John?
Tom is taller than John.
So here this is very interesting. So if you watch the dialogue, then you see that this question regarding John here appears first time. So this is the proof that there is no chat log behind, because this is a new situation, and Robina applied the correct rule to this new situation.
What is heavier, a car or a ship?
A ship is 30,000 kilograms. And Hamburg. And Munich.
A ship is heavier than a car.
Thanks. I hope I don't forget this.
Also, a color is green. Is a car heavier than ship?
No.
What is Munich?
A city in Germany.
Manfred weighs 80 kilograms. How many colors know you?
I know 3. Red, yellow, and also green.
What is Hamburg?
A city in Germany.
Who is heavier, Manfred or a ship?
Ship is heavier than Manfred.
Is Manfred heavier than a ship?
No.
Is Manfred lighter than a ship?
A ship is 30,000 kilograms.
Manfred is lighter than a ship.
Okay. I will remember this.
City in Germany.
Hamburg. And Munich.
What time is it?
Yellow. And Hamburg. And Munich.
So here I will demonstrate now how to connect some interface to Robina. Time is a part of the operating system, so here this interface comes in place, and I have to connect now this interface to Robina, and to make it easier I put here some buttons, and behind this button there is the connection algorithm which connects the driver with Robina.
The rules about time.
Thanks.
What time is it?
It is now 1423 and 25 seconds.
What is the clock?
Is yellow.
So here I changed the question, and I have connect the interface to this question.
The rules about time.
Okay. I will remember this.
Is a ship lighter than Manfred?
No.
What date?
Is yellow. And light gray. And Hamburg.
The rules about date.
Thanks.
What date?
Today is July 31st, 2016.
What the clock is?
It is now 1424 and 21 seconds.
Is Tom lighter than Mike?
Yes.
How do you feel?
My knowledge so far provides no correct answer.
So now I will demonstrate that it is possible to connect some interface with variables. Here the feeling is represented by numbers from 1 to 11, and the number 5 produces a special answer, but first I have to connect the interface to Robina.
The rules about feeling.
Thanks.
Blinker left on.
I don't know this command.
And now I connect some action interface to Robina. Here we have two actions, blinker left and blinker right.
How do you feel?
Not good.
And I can change here now, for instance, the number and ask Robina again how she's feeling.
How you feel?
Very good.
So these answers here are programmed in the interface because this is application and operating system dependent.
How is the weather?
Hot.
So here I also can change sorry, the number or the variable and ask Robina again.
How weather is?
Hard. And hot.
Sorry, I first have to connect the interface
The rules about weather.
to Robina.
Thanks.
I forgot this.
I hope I don't forget this.
So now I ask her again.
Weather now.
Cold and rainy.
And I change the number here.
Is how weather.
Blue sky.
How weather.
Blue sky.
How do you doing?
Very good.
Blinker left on.
I don't know this command.
So now I have to connect the blinker action to Robina.
Number blinker.
Thanks.
Blinker right on.
Blinker left activated.
Number blinker.
Good to know.
Blinker right on.
Blinker right activated.
Blinker right off.
Blinker right activated.
Number blinker.
Thanks.
Blinker right off.
Blinker right deactivated.
Blinker right on.
Blinker right activated.
Blinker left off.
Too much associations. I am a little bit confused.
Number blinker.
Thanks.
Blinker left off.
Blinker left deactivated.
Blinker right off.
Blinker right deactivated.
So this was the demonstration of these 4 basic functions or principles of information processing.
Now I will demonstrate 2 of the, from my opinion, most important parts of intelligence: induction and deduction. And again, induction and deduction needs a tutor, a filter which separates right from wrong. And as I mentioned before, this tutor not necessarily has to be a person. This also can be Mother Nature. But how do Mother Nature come into our brain? Well, via our 5 senses: visual, auditive, olfactoric, gustatoric, and tactile. These are the 5 senses, and each of these senses has its own area in our brain where the signals are processed, but these areas are not isolated. They are interconnected, and they are also interconnected with the cortex. So in these areas, induction and deduction takes place, and also in the cortex, induction and deduction takes place. But what happens here is, and it's very easy, but it's very, how to say, hard to discover, that these areas, one area plays the tutor for another area. So the miracle words are mutual tutoring. Mutual tutoring. There's a very important function in our brain. And unfortunately, Merlin, the software I will demonstrate now, has only one sense. Merlin is only able to listen again, and so I have to substitute the other senses, and I have to substitute the tutoring of the other senses. So, okay, let's start with the demonstration.
May I introduce Merlin? Merlin starts, like Robina, with one neuron. So let's see what happens. I explain Merlin now the world, and please be aware that Merlin now do not know more from the world than these 9 words. So here we have the first induction. I call it association, but indeed it is an induction. And to understand that, I have to tell you a little story. A professor in the area of artificial research years ago told me that, Manfred, if you can show a reaction from a program which is not pre-programmed, then you really have something. So how to say, here nothing is pre-programmed. There is no list behind, there is no pre-programmed functions, no pre-programmed answers or whatever. Every reaction comes from the neural net itself and from the surrounding basic principles of information processing. So as I am the tutor here and this induction is correct, I will confirm it. So this, this induction also is correct, and this as well. So the order of the words doesn't matter, because to learning the syntax of a language is the next step of development. And here we have the first deduction. If trouts have eyes, then pikes have eyes. This is a deduction. And it is correct. And here you can see, I put in here the information about something new, about shells. And so you can see that there is no, how to say, function behind which maybe randomly mixes the words or whatever, because in these 3 sentences there is no embedded or intrinsic induction or deduction, so the system do not react here. So these are all correct inductions, but this induction, of course, is wrong. But as I said before, wrong inductions are okay because they are logical. If you see this, regarding to this input sentence here, they are correct. So in the intrinsic logic, they are correct, but compared to the outer world, they are wrong. So I disconfirm this induction. But this induction is correct. and also this deduction. You see here all the time the inductions are correct. Oh, that's my fault now. Carbs have no pairings, but it doesn't matter. I can correct that later. Some animals have pairings, I have to confirm here. Here I have to confirm the not. The conclusion is inverse. So what you have seen here do not look very spectacular, but it is. I searched the internet up and down, and I have never seen no company, no one is able to demonstrate induction and deduction in this perfect manner. And please be aware that induction and deduction has something to do with logic, with predicate logic and proposition logic. And so I will show you now the result of the neural net, but what you see is an abstract of the predicate layer. And just for your information, the net and the functions are able to deal with in the predicate logic with predicate and subjects, and the most difficult part is to handle items which are predicate and subject in the same time.